Bienvenidos, Hushamdi, and happy holidays, and welcome to this HUD 8 networking techtorial on enterprise networking, security, and automation from the CCNA version 7 curriculum. This is Packet Tracer Activity 2.2.13, where we're going to be covering point-to-point single-area OSPF. So, what can you expect to learn in this video techtorial? I'm going to be talking and configuring OSPF in the Packet Tracer activity, where we're going to talk about the OSPF Router ID. We're going to see 3 different ways that you can enable the OSPF process on an interface. We're going to talk about the passive interface command and why we might want to use passive interface on LAN-facing interfaces. And then we're also going to take a look at a number of different validation and verification commands that we can run in our OSPF environment. I'm even going to be pulling up a number of live Cisco physical routers, 2811s, and we're going to be looking at Wireshark to see exactly what the OSPF multicast hello packet looks like. All right, so let's go ahead and dive in with the activity here. And again, this is activity 2.2.13. Now, this is totally new, the curriculum. And so one of the things I really like about what they've done here is in the subnet mask field. They no longer place the subnet in dotted decimal notation. Now they simply place it in the classless interdomain routing format, or the CIDR notation. You'll also hear this referred to as the slash notation. So instead of seeing 255.255.255.0, we're now seeing /24. And so this gives you, the learner, the opportunity to practice your subnet skills in terms of recognizing a /24 is the 255.255.255.0, or the /30. What would that be? And so you've got to figure these things out. And so this is a great addition that has been made here to the Packet Tracer activities. Now, the first thing that we're going to do is we're going to configure router IDs. Now, to be clear, the router ID is the most important value to OSPF on the router on which it's configured, because I want you to think of the router ID as being like the router's OSPF fingerprint. Everybody has a fingerprint and they're all unique. And the router ID needs to be unique as well. And as you can see here, we're configuring 3 different values. Now, let's go ahead and open up each of the routers in turn, and we'll configure that router ID value. So we'll go from user exec mode to privilege exec, then into global config, and I'm going to say router OSPF, and the process ID that we're using is going to be process ID 10, and you can see that indicated right here. Now, a quick note on the process ID. Remember, the process ID is locally significant, and what that means is that the process ID with OSPF does not have to match between the different routers in order for OSPF to work. Now, when you move on in your studies and you go into the CCIE realm and you start to talk about technologies like multi-protocol label switching, or MPLS, you'll find out that the OSPF process ID does have use cases where you would want it to match, or you could leave it so that it doesn't match. But again, those are far more advanced use cases than what we're discussing here, but I just want to make sure that you're aware of that. Because a lot of times you'll hear people say that the process ID is locally significant and it never has to be the same. In this context of the CCNA, that's a true statement. However, as you move on, that might change. So we say router OSPF 10, and then the command to add in the router ID is simply router-ID, and for router 1, I'm simply going to say 1.1.1.1. Now, I also want to give you some additional pointers here. Now, the 1.1.1.1 is a good value, and there's no question that we'll be able to identify in this topology that that represents router 1. But let me offer up another alternative that you can use that would never be confused with an IP address, and that's router ID 0.0.0.1. Now, we're not going to get the points if this is the value that we use, and so I'll pull this back, but I just want to give you the idea and the thought that these might be better values that you won't mistake later for an IP address. And you'll see what I mean when we get into the validation and verification commands. So again, I'll pull that command back, but something to consider. And in the environments in which I perform the OSPF administration, those are the types of values that I'm using, values that can't be mistaken for an IP. So we've got our router ID here for router 1. Let's come over to router 2, and we'll do much the same thing. Now remember, this is the new CCNA version 7 curriculum, and I'm using Packet Tracer version 7.3. That is the minimum version to successfully, or to be able to successfully complete any of these activities. So you want to make sure you're using Packet Tracer version 7.3. I'll go into global config, I'll say router OSPF 10, and then I'll put in my router ID value of 2.2.2.2. Now, as I do that, you'll notice down here it's very small, but in the right-hand corner, my completion percentage is now at 11%. And as I'm completing the tasks that I'm being asked to complete, that value will continue to increase. So let's pull router 3 up. Now on router 3, we'll go from user exec to privilege exec into global config. I'll say router OSPF 10, and then we'll put our router ID value in here of 3.3.3.3. Now the completion percentage just jumped to 16, so we know we're doing something right here. So part 1, configure the router ID. Now, as we're going to see, the router ID is a critical value, the most critical value, and it needs to be unique in your OSPF routing domain. And again, think of that OSPF router ID as the OSPF fingerprint, and that everyone has a fingerprint and they need to be, and they are unique. So now we're going to configure networks for OSPF routing. Now, this is another change to the curriculum that I absolutely love. In the previous version of the Cisco Networking Academy curriculum on OSPF, they never talked to you about how to configure the OSPF process on an interface. They showed you the network commands and how to do it in the OSPF global configuration section, but they didn't show you how to do it on an individual interface. And the new version of this curriculum does show you that. In fact, if you look at step 3, you'll see that they demonstrate that. Now, let's go ahead and answer the questions here. It says configure networks for OSPF routing using network commands and wildcard masks. How many statements are required to configure OSPF to route all the networks attached on router 1? Now, I'm reading this question here as if they're talking about how many network statements would be required on router 1 for each of the networks on router 1. Well, if we were to scoot back up here, we can see that router 1 has 3 networks. So there would be 3 network statements required to properly configure each of the interfaces there to run the OSPF process. Now, this might be considered a trick question of sorts, because you can actually put in a single network statement that encompasses every single interface on the router. And I'm actually going to show you what that would look like. But first, let's go ahead and configure the interfaces that are on the router here. So if I say do show IP interface brief, and that way I don't have to roll back up in the right-hand side of the window over there, I can see the network statements, or I could see the networks I have here, and I know that the gigabit Ethernet, that is my LAN-facing network. Now, this is facing a switch and then a PC. And in your network, it could be multiple PCs. And when we get to the passive interface, I want you to consider and give some thought to the idea of why would we passive the LAN-facing interface. And I'll talk about that in detail. But let's get our network statements in. So I would say network 192.168.10, and remember, I'm not putting the IP address in here on router 1. I'm putting in the network ID or the subnet, and that's 192.168.10.0. Now, when we're configuring OSPF, we have to put the wildcard mask in. Most learners might become confused and do something like this. But that's not the wildcard mask. That's the network subnet that's the subnet in dotted decimal notation. So let me pull that back. Now, the proper wildcard mask is going to be 0.0.0.255. And you might be asking yourself, well, how did you get the wildcard mask? How do you know that that's the value? And if I pull my drawing tool out here, as a review, remember the wildcard mask is very, very simple to determine. If I place all 255s, in other words, 255.255.255.255, and I subtract what the subnet mask is, not the wildcard mask, but the subnet mask for the network in question, and a /24 we know is 255.255.255.0, where the first 24 bits or the first 3 octets are the network bits. And then the last 8 bits or the last octet, these are the host bits. And so all you do is subtract from all 255s the actual subnet mask. In this case, a /24 insider notation is 255.255.255.0, and that gives me 0.0.0.255. And that is my wildcard mask, and I'll just say WCM. And that's going to be the value that we place in here with our network statement in OSPF. So let me go ahead and clear the screen here. And let's go back to the configuration section. And this is going to be area 0. All right. Now, what about the next 2 networks? So we've got serial interface 010 and serial interface 011. So let's say network 10.1.1.0, because again, we don't put in this context and what we're being asked to do, we don't put in the IP address of the interface. We put in the subnet ID of the interface. Now, if you remember from peeking earlier up here, we saw that the 2 serial interfaces here, and the same is true on all of the routers, that the serial interface subnets are /30s. Now, again, I like what they did here, where it's going to force you to think, okay, if it's a /30 insider notation, what would that look like in dotted decimal notation? Because we're going to need that value in order to calculate the wildcard mask. So let me walk through, and I apologize there, let me walk through this example in a little more detail. So a /30, remember that means that the first 30 bits, 2, 3, 4, whoops, and I didn't want that. 2, 3, 4. Sorry about that. My pen is giving me extra characters. 2, 3, 4. So the first 30 bits, and there's 28, and then 29. I'm sorry. There's 24, 25, 26, 27, 28, 29, 30. So we only have 2 host bits. So when we look at this, we can easily convert this from binary, right? So this is binary. So it would be 255 dot 255 dot 255 dot, and now we need to figure out what the value in the 4th octet is going to be. So remember, going from left to right in this octet, our values are 128 and then 64 and then 32 and then 16 and then 8 and then 4 and then 2 and 1, but those are the host bits there. So 128 and 64 is 192. 192 plus 16 is, 192 plus 32 is 224, plus 16 is 240, plus 8 is 248, plus 4 is 252. And so that's the subnet mask in binary. This is the subnet mask for a /30 in dotted decimal notation. And now that we have this, we subtract it from the all 255s. And I don't even need to write that out. We should be able to simply say that it would be 0, 0, 0, and then 252 taken from 255 is going to give me 3. And so that would be the wildcard mask in this network statement. And this is one of the reasons that Cisco likes to focus on the network statement, because it adds a level of complexity, a little difficulty that you'll be dealing with. And then we'll say area 0. Now, if I know that that is the statement for the 10.1.1.0, for the 10.1. Let's get the network in there. For the 10.1.1.4, this is going to be easy. And then for all of the other routers, it's also going to be very simple, because that /30, we have it worked out. The wildcard mask will always be 10.1.1. The wildcard mask will always be 0.0.0.3. All right, so I've got my 3 network statements in there. And those are the network statements you would need to add for all 3 of the networks on router 1. Now, that statement there, how many statements are required, or I should say the question, how many statements are required, I could have said the following. And that will actually enable OSPF on every single interface that has an IPv4 address configured on it. And so again, maybe put that away and hold on to that, because that's a quick and easy way, if you're labbing things up and you're just trying to get a dynamic routing protocol running, that's a quick way to get it running on all interfaces on your router. So let me go ahead and pull that back. But that again is a little configuration tip that may help you down the road. Excuse me. So the next question was, the LAN attached to router 1 has a /24. What is the equivalent of that mask in dotted decimal? Well, we talked about that. It's 255, 255, 255, 0. And then it said subtract the dotted decimal mask from the all 255s, and we saw what that result would be. We did the dotted decimal notation. In fact, we looked at the binary representation for a /30, and we worked out our wildcard mask by subtracting the dotted decimal notation from the all 255s. We configured the router 1 with the correct wildcard mask for all of the networks using the network command. Now, verify OSPF has been configured properly by displaying the running configuration. Again, here's where the value add of watching the video comes into play. Watching this video comes into play. Now, you'll notice it says show the running configuration. If I say do show run and hit enter, I have to either hit the space bar a number of times, maybe I jump past the OSPF configuration, or I could hit the return key to go a line at a time. This is one of the changes, one of the great additions that Netacad has added into the Packet Tracer 7.3, is I no longer have to say do show run and hit enter and page down, or hit the space bar and hope that I get close to the OSPF config section to see what I have configured. They've added this command in, and I actually have packet tracer 7.2.2 running on an older iMac I have next to me here, and I actually validated this before recording this video. This is how you should be running the command. Do show run, pipe it to section router OSPF. This will only show you the router OSPF configuration section, and that is the section that we're interested in. If you say do show run, depending on how much configuration you've done to this router, it could take you a couple of seconds to actually find what you need, and you may blow right past it. So they've added in the ability to use the pipe command and to pipe it so that we can use options like section router OSPF. So be sure to write that command down. That is a great command to have, and it works for other things, not just OSPF. You could say do show run and pipe section router EIGRP, section router RIP, section router BGP. So this command has a lot of applicability. It's a command I use on a daily basis because if I just want to see the OSPF configuration stanza, that's how you get to it. So again, try to avoid that do show run because it's going to show you a whole bunch of things that you really don't need to see. So verify OSPF has been configured properly, and I think that we're good to go on router 1. Now it says if you find an error, you can use the no command to reconfigure it. And actually, let me show you what that looks like. So I would say no, let's say the network 10.1.1.4 is wrong. I could say no network 10.1.1.4 0.0.0.3 area 0. Now, you'll also notice my score just dropped down here in the lower right by 6 percentage points. And that's because I removed a command that we actually need, 10.1.1.4, 0.0.0.3, area 0. And so now we're back to that 33% we had before. All right, let's come to step number 2. Configure networks for OSPF routing using interface IP addresses and the quad 0 masks. And so this is another approach that was never discussed in the version 6 curriculum. So in the previous curriculum, it was all about the network statement. And this is another huge value add because this is actually considered a best practice. And if you go on to the CCNP or you go on to your CCIE down the road, this is how you might be asked to configure it. And I've actually sat for the CCIE lab exam 2 times. So this is definitely an approach you want to become familiar with. So let's talk about and configure this and see what it looks like. So here's router 2, and actually I can actually squeeze this in so we can see our directions there. So here we are on router 2. If I say show run pipe section router OSPF, because I only want to see what's in the OSPF configuration section, I've got my router ID. Now that log adjacency changes, that is auto-magically put into the configuration for you. So let's go from privilege exec to global config. I'm going to say router OSPF and then the process ID we're using, which is 10. Now, this is asking me to use the interface IP address in the quad 0 mask. So what would that look like? Well, let's first see do show IP interface brief. So again, I have 3 interfaces on which I would like to run the OSPF process. Now remember, as I'm adding in these network commands on each of the interfaces are actually sending hellos out via multicast to the address 224.0.0.5. In fact, let me digress and let's take a step back here. Let's come back to router 1 and I can say debug IP OSPF, and if I do a question mark, you can see we can look at adjacency events or we can look at OSPF events. Now, when we have any type of an adjacency event, this would give me additional information. What I don't see here, and let's back up and I can say events, What you don't see here, and it looks like this may have changed because I could have sworn that the Debug Ip Ospf packets was an option on previous versions of Packet Tracer. But don't worry, I've got real Cisco routers that we'll be able to take a look at to see the whole selection of debug commands that we have, or options we have with the debug command. And so let me do that. Let's take a quick break here. If I come over to router 8, and again, this is just a router I've got set up, and I say show IP interface brief, you can see that this router has a fast Ethernet interface, but it also has a serial interface. So I'm going to go ahead and go into global config. I'm going to say router OSPF10, and I'm going to set the router ID on router 8 to 0.0.0.8. Again, a value that you would never mistake for a valid IP address. And let's go ahead and add the network command in for the 10.8.9.8. Now, here I'm using the exact IP address on that interface with the quad 0 masks. And the reason for this is that this will enable the OSPF process on that interface and only that interface with the quad 0 mask. And then we'll put in area 0. Now, as soon as I hit enter, if I was to say debug IP OSPF and do a question mark for you, you can see that the real Cisco IS, and this is 15.1 code, so it is a little older, but you can see that we have lots of different options from which to choose. In fact, the packet option is the one that I'm most interested in because I've enabled OSPF on the fast Ethernet interface on this router. I'm sorry, I want the hello. I've enabled the OSPF process on the fast Ethernet interface. And so every 10 seconds, I should see a hello message being sent off of this interface. And right on time, we see exactly that. Now, if you watch the timer here, the next one's probably going to come, and it's never exactly 10 seconds, but very close. And you can see every 10 seconds, a multicast hello is being sent out to the 224.0.0.5. That is the all OSPF routers multicast address. And I want you to think of it like this. Every 10 seconds, this router, router 8, is sending out on that broadcast network segment, that Ethernet interface, right, that goes out, we could say it goes to a switch maybe, and it's broadcasting to anybody else running OSPF who would be listening for this address, listening for messages on this address. Other routers that are listening are going to say, hey, that router wants to talk OSPF. I want to talk OSPF. Let's go ahead and see if we can form an adjacency. And so these are the hello packets that OSPF is sending. Now, let's take a look at Wireshark here, and let's see the information that's inside of these hello packets. And so we may need to wait a few seconds here, but we will eventually see, and that's the one we're looking for. I can stop my capture right there. So you can see the source address, 10.8.9.8. That is the fast Ethernet interface on router 8. You can see the destination to the all OSPF routers. In other words, anybody listening on multicast address 224.0.0.5. And this is my hello packet. Well, let's see what's in the hello packet. If I open it up here, you can see we've got the OSPF header. You can see it's ID'd as a hello packet, and then we have the LLS data block. Let's take a look at the header and see the information that's in here. You can see it shows it's OSPF version 2, so we know it's for IPv4. The source OSPF router, there is the router ID value. And that value is critical because it has to be unique. And I'm going to expand on why it's critical right now. The reason the OSPF router ID is so critical is because OSPF uses that value to uniquely identify this router in the OSPF shortest path first graph. Now remember, OSPF is a link state routing protocol. And it's also a routing protocol that uses the shortest path first algorithm. In fact, it's Dijkstra's algorithm. In other words, you'll hear it referred to as just Dijkstra's algorithm. And in Dijkstra's algorithm, it creates a tree. And in that tree, you have leaves or nodes on the tree. And so how do we identify those nodes uniquely so that we know who we are trying to communicate with? We use the OSPF Router ID. Now, you can see the area number. Wireshark displays it in the dotted decimal notation. 0.0.0.0, in other words, area 0. And you can see they even put in here the backbone area. We don't have any authentication, so that's okay. Let's take a look at the other values in the hello packet. We see the network mask, right? Remember, we added that wildcard mask in there. Here, it's converted to the subnet mask. We see the hello interval is 10 seconds. There's some options we have here. The router priority, which I'm going to talk about toward the end of this video when we're going to talk about the designated router and the backup designated router as a segue into the next packet tracer activity. We have the router dead interval of 40 seconds. We can see that the designated router is in fact router 8 and that there is no backup designated router. Remember, we've only configured OSPF on router 8's interface on that Ethernet network. All right, well, that was a nice little segue there to take a deeper dive look at what exactly is in the hello packet, why the values that are in here matter, and what we would see if we were doing a packet capture. And now we know that the other routers in our environment here are going to be listening. Once we start OSPF up on their interfaces, they're going to be listening for those multicast packets. So back to router 2. We're going to say network 192.168.20.1. Now remember, we're not using a wildcard mask based on the subnet mask. We're using a wildcard mask of quad zeros, which is going to lock the OSPF process down in this command to that specific and exact interface on this router. Now, if you're asking yourself, well, why would you want to do that? Remember, if I was to use the /24, right? I could do that, but I could also have other interfaces, logical interfaces like loopback addresses, on which I configure a /32, which is known as a host route. And if that value fell within the /24, we may mistakenly or unwittingly start OSPF up on that loopback address, right? Or advertise that loopback address into OSPF, and we might not want to do that. So this is why we would want to lock it down. And again, this is considered a Cisco best practice and something you'll see more and more as you move on in your studies. Now, let's go ahead and finish this up. We're going to say network 10.1.1.2, and I'll put my quad zeros in, area 0. I'm going to say network 10.1.1.9. Quad zeros, area 0. Now, you'll notice that we have a neighbor relationship that has just gone from loading to full. Now, loading is the penultimate state of the OSPF finite state machine, or F as in Frank, S as in Sam, M as in Mary, FSM. And it transitions through a number of states. But ultimately, it will end up telling you it's gone from loading to full, meaning it's fully adjacent with the neighbor 1.1.1.1. Now remember, that is not representing an IP address. That value is the router ID. And so hopefully you're seeing how that router ID could be confused could be confusing when you look at it. You might be thinking to yourself, is there an IP address of 1111 on router 1? Where where's that value coming from? And it could be a loopback address on router 1, in fact. So that's why I prefer in the real world using 0.0.0.router number. All right, that takes care of router 2. And here we go. Okay, great. So we can see that we are receiving the hello packets. And if I say show debug, that would show me the debugs that are on. And again, OSPF adjacency and events. With this, we're seeing that we're receiving those hello packets. So if I want to turn the debugging off, because I don't want to see that anymore, I can just simply say undebug all. And that turns everything off. And it's undebug all is the full command, but all you really have to say is uall. And that is going to do the exact same thing. Okay, on to step number 3. So now we've seen 2 different ways that we can get the OSPF process running on an interface. The network command with a wildcard mask based on the subnet mask. And that was the first way. The second way, and what we just did on router 2, was using the exact IP address of the interface and the quad 0 wildcard mask value. So now what we're going to do is we're going to use, and I love how they've added this into the curriculum. This was never discussed in the previous curriculum. And typically this is how I go about doing my OSPF interface activations, as I go onto the interface and I will use this syntax. So let's get on to router 3 and let's see what this looks like. Because with this syntax, I don't need to know what the subnet mask is. I don't need to know what the IP address is. I don't need a network command at all. So let's say show IP interface brief so we can see the 3 interfaces that we want to run OSPF on. Let's go from privilege exec to global config. And I'm going to go into interface gigabit Ethernet 0/0/0. Now, this syntax, IP OSPF, now the process ID, this is where it has to match. Whatever we've configured as our global OSPF configuration section, that process ID number has to match the number that I'm putting here on my interface. Or let me put that in reverse terms. The value I'm putting here on the interface for the OSPF process ID has to match the global OSPF process ID, or else it won't start OSPF on this interface. So I say IP OSPF 10 area 0. And for me, this is the easiest way to perform the configuration. And that's going to start the OSPF configuration up on that interface. Now, let's go ahead and go into interface serial 010. And now I can just hit the up arrow. And we should see an adjacency go from loading to full. And there it is with router 2. Let's finish this up by going into interface serial 011. And then we just need the up arrow a couple of times and recall the previous command, because that ensures we don't have any typos, right? And if you're using the same area and it's the same OSPF process ID, you're going to go from loading to full. All right, so those are the 3 different ways you can enable OSPF on a router interface. Absolutely fantastic. Big thumbs up here to Netacad for expanding this out and covering the multiple different ways to do this. All right, now we're on part 3, the final part. And this is where we're going to talk about passive interface. Now, there's a number of ways that we can approach this. First, let's talk about why passive interface is important. So remember that the passive interface command is going to stop OSPF from sending those hello messages that we looked at in Wireshark. And let's come back as a quick refresher here and take a look at these values. And remember, sorry about that, let me scoot that back up. And remember, the reason that these values are important is because these values give you all the information you would need to know to completely destroy this environment from a routing perspective. When I look at this, I can see the router ID of router 8. I can see the area number that router 8 is using on this interface. I can see that there's no authentication. I can see the subnet mask. I can see the DR, BDR priority value. And I'll come back to why these are so important here in just a second. So let's go ahead and come over here to router 1, and we'll do these in turn again. Now, I said there's multiple ways to do this. So let's go from privilege exec into global config. I'm going to say router OSPF 10. Now, this is showing us how to do it, and I would have preferred, and I guess this is, I don't create these, so I have all the respect in the world for the individuals that do. And I say the same thing when I talk about things that I read in different texts. So what would have been great here, and this would be my recommendation to the Netacad team, is just like you showed me the 3 different ways to enable the OSPF process on an interface. It would be great if you would show me the multiple different ways that I could passive an interface. And I'll show you the different ways right now. So the first way is they want us to do the passive interface command and then simply put the interface in there, and only on the LAN interfaces. Remember, those hellos are responsible not only for discovering our neighbors on a network segment, those OSPF hellos are also responsible for maintaining the adjacency that we've established. Because every 10 seconds, I'm expecting to receive an OSPF hello from the neighbor with whom I'm adjacent. And after 40 seconds, remember that dead interval that we talked about here. So if every 10 seconds I'm supposed to get a hello, an OSPF hello packet, after 4 of those don't show up, that would be 40 seconds, this OSPF adjacency will get torn down, and it will break my adjacency with my neighbor, and it could impact connectivity in my environment. So the hello messages are very important. But remember, I just said that the hello messages are important when they're between routers, right? So that interface and this interface, or this interface and this interface. That's where it's important, because there's routers on the other end of these interfaces. And I've got adjacencies with these routers that I have to have because I'm setting my network up to run OSPF. So we need these adjacencies to exchange routing information, to discover my OSPF neighbors, and then to maintain those adjacencies. Now, on a LAN interface, and let me change my color to red here. On the LAN interfaces, are there any other routers out these interfaces with whom I need to establish and maintain an adjacency? And the answer is obviously no. In fact, the only thing that's out here, other than the switch, which the switches are not running OSPF, the only other thing out here are the PCs. So the reason that you would use the passive interface command on the LAN-facing interfaces where there are no other routers with whom you're trying to establish an OSPF adjacency and then maintain that adjacency is because we don't want the hello packets being multicasted out to a LAN segment. Now, ask yourself that question. Why might that not be a good thing? To multicast out the OSPF hellos on a LAN segment where you have users sitting at PCs who might become very bored during the day, who might be able to install Wireshark on their PC and watch and see all the traffic that's coming across this network segment. I've actually seen this happen in a couple environments that I've been in, and not recently, but a ways back. But if they have Wireshark on their PC and they're sniffing the wire, they're going to see this traffic. And if they can see this traffic, they can see everything they need to bring this network down. And here's how they would do it. you would see the interface, you would see the hello packets. I would simply go ahead and get some software on my PC that would allow me to configure OSPF on my interface on the PC. I could use my router ID as 0.0.0.8. And then I could start advertising the same networks that might be advertised on the local area network. And that will quickly disrupt your OSPF operations. So first and foremost, the passive interface command stops the sending of hellos on the LAN segments for security purposes, first and foremost. Now, the second reason is it's a waste of resources. Not only resources on the router, but resources on all of the other devices that might be listening for traffic on the network, right? Because no one here on this LAN segment should be running OSPF. So it's a waste of resources on the router. It's a waste of resources on anything else that would be processing those hello packets. Now, those are the two reasons to do it. Let's go ahead and make the configuration here by saying passive interface gigabit Ethernet 000. Now, on all three routers, that command is going to be the same. So let's come over to router 2. Let's get logged in and go from user exec to privilege exec into global config, into router OSPF 10, and say passive interface gigabit Ethernet 000. That should take me to right around 94. And then if I say router OSPF 10, passive interface gigabit Ethernet 000. So let me go ahead now and show you another approach that you could take when configuring the passive interface command. So that's one way to do it. And when there's only one interface that needs to be passive, this may be the preferred way to do it. So if I go over to router 8, and let's actually go ahead and turn off the debugs by saying you all. Another way that I could do this, if I go into router OSPF 10, is I can say passive interface default. And this is actually how I approach it, is I say passive interface default. And as soon as I do that, OSPF is no longer sending hellos on any of the interfaces. In fact, if I say do debug IP OSPF hello and I hit enter, let's see what's happening right now. Because every 10 seconds, if what I told you is not true with that passive interface default command, within 10 seconds, I should see a hello. And as you can see here, there's no hellos. So I use passive interface default because that forces me to come back later, right? And to individually say no passive interface fast Ethernet 00. So I have to intentionally come into the OSPF configuration and I have to intentionally no passive the interfaces that I want participating in the OSPF routing process. And the reason I like this method better is because, again, it forces you to come in and intentionally no passive the interface. Because if you only passive one interface, let's say that you go and you configure a new interface on the router and you don't remember to go in and say passive interface loopback 50 or loopback 0 or whatever the new interface may be. Maybe it's an interface that's connected to another router, but you're not running OSPF, right? If you're intentionally using the passive interface command, you have to remember that every new interface you bring up, you're going to want to go back in and say passive interface and then that interface. When you say passive interface default, you're protected from mistakenly bringing an interface up and then possibly having OSPF start running on that interface for whatever reason, right? And so that's why I like the passive interface default. And you can see as soon as I said no passive interface, the hello messages start to flow again. All right, so we are at 100%, as you can see in the bottom right-hand corner, but we've got some OSPF show commands that we definitely want to talk about here. So I'm going to use router 3 as my candidate here. And let me save my configuration. So one of the first commands that you might want to run is show IP OSPF interface. And if I do a question mark, there's an option here that I don't see that I wish they had. And the option is brief. Show IP OSPF interface brief. Now, what they would like us to do here is to say gigabit 000, and it's going to show me the information about that interface. Now remember, gigabit Ethernet 000 will be a broadcast network type. And there are 6 network types. Now, one of those network types, we may make the argument, is not really an OSPF network type. But let me talk about that in just a second. So the 6 network types are broadcast, like you see right here. If I was to recall that command and say serial 00, I think it was 010, there we go. A serial interface is going to be a point-to-point interface. An Ethernet interface that's plugged into a LAN switch here, that will be a broadcast interface. Now, there's a significant difference between these two interface types. And the most significant difference is the fact that on point-to-point OSPF networks, which is what this video is all about, there is no DR-BDR election. Now remember that. On a point-to-point OSPF network type, there will not be a DR-BDR election. Well, how could I see that? Well, let's say show IP OSPF Neighbors. And here's where you would look to see who is the DR and who is the BDR. Now, these are the interfaces I have neighbors on. You can see again, that's the router ID. That is not an IP address configured on router 2, just as this is not an IP address configured on router 1. Here's the IP address on which the adjacency has been established. And there's the outgoing interface on this router over which that adjacency with router 1 has been established. But it's right here where we see that dash. And that's typically where you're going to see one of 3 things. It's going to say DR, or it's going to say BDR, or it's going to say druther, DR other, which stands for druther, which means it's not the DR and it's not the BDR, but it is an OSPF router that we are aware of on our network. So let me go back over here to router number 8, and let's say do you all to kill the debugs. And I'm going to come to router 9 because router 8 and router 9 are actually not connected to each other, but they have communication with each other. If I was to say do ping 10.8.9.8, you can see that router 9 can reach router 8. So let's say router OSPF, and to prove to you that the process ID doesn't have to match, what kind of values can I use here? I'm going to say, whoops, went to one too many there. We'll say 9,999. A crazy process ID number, right? But it's to show you that this adjacency between router 8 and 9 will work, and I don't have to have the process IDs match. So let's go ahead, and I'm going to say passive interface default, no passive interface, fast Ethernet 00. This is another way to deal with passive interfaces. Now, what am I doing here? Let's go ahead and say, and actually let me do my preferred method. I'm going to go to interface fast Ethernet 00 and say IP OSPF IP OSPF 9999 area 0. And what we should see pretty quickly here is we have an OSPF adjacency. Now, what's going to be different between this adjacency over a fast Ethernet broadcast network type? Again, if I say show IP OSPF interface brief, this is the option that I would like to see in Packet Tracer that's not there, because this is going to give me some really quick information, and it's going to tell me the cost. It's going to give me the state. It's going to tell me how many neighbors I have, right? So this gives me a lot of nice consolidated view, a little different than if I said fast Ethernet Now, this clearly gives me additional information, right, that I can do a little deeper dive. Now, let's go ahead and come back with show IP OSPF Neighbors, and let's get this all up here on the same screen so that we can have a quick conversation. So when I say show IP OSPF Neighbors, you can see that the neighbor ID, that would never be mistaken for an IP address. A little easier to read. My priority, that's the default priority for an OSPF router on a broadcast network segment. And here is where you see DR. Now, this is very tricky. That is not what router 9 is. Router 9 is not the DR. Router 9 is the BDR. So this is reflecting the DR BDR status of the other router, of this router, router 8. And we see that here. Oops, sorry. We see that right here. The designated router is router 8. But if on an exam or a quiz, if this is all you're shown, remember that that is not the state of router 9. Router 9 is not the DR. That is indicating that router 8, this neighbor, is your DR. And so again, keep that in mind, very, very important. And we see here that it's a broadcast network type. And again, it lists, sorry about that, it keeps moving. It lists out the designated router and it gives me the ID of the backup designated router. And again, the BDR, which is router 9, has this crazy value because we never set the router ID on router 9. So let's do a little sidebar. What if I said router OSPF 9999? If I wanted to set, if I realize right now, you know what? That is not a good router ID value because if I come over to router 8 and I say do show IP OSPF neighbor, you can see that this is the router ID value. But very quickly, it may become confusing when you're looking at output like that. So we want to fix this. I want router 8 to match my best practice approach. So I'm going to say router ID 0.0.0.9, and I'm going to hit enter. And you'll notice that it doesn't take effect immediately. Again, the router ID is the fingerprint of this router in the shortest path tree. So, excuse me, what we have to do here is we need to make sure we're very, very specific. And I'm going to say clear IP OSPF process, or you could just say proc. And I'm going to hit enter. And it's going to ask me, oops, sorry, we'll say do there. Let's Control A, do. So do clear IP OSPF proc. And it's going to say reset all IP OSPF processes because this is a very dangerous command. If you say yes, and you're doing this in a production environment, this is what I like to refer to as a resume generating event. Because this is going to take your network down while it recalculates the shortest path tree. Because we've just changed the fingerprint for router 9. Now, it did what we wanted it to do. It's going to change the router ID, and this is actually going to disappear here. You can see, and actually this is, I like to see this here, right? So you may look at this and say, well, wait a second, how come I've got 2 adjacencies? Well, you don't, and you're about to see that you don't, because you'll notice that dead timer is counting down from 40, right? We were here at, and there it goes. And it took it down. So that was a bogus entry, right, that we no longer were using. And now this is the entry we were waiting for. But again, we cleaned it up, but you'll notice it held on to it for 40 seconds before it got rid of it. So be aware of that as well. And it's telling me that router 9 is the backup designated router. All right, so those are some good commands to run to see what's going on in your environment. Show IP OSPF neighbors, show IP OSPF interface, and then the actual specific interface. When you're on Packet Tracer, the brief option isn't there, but that's a great option to go to on real Cisco routers. Another command that is very valuable, show IP protocols. This is going to show me the routing protocols that are running on this router. If I was running EIGRP and BGP, I would see those here. And again, this shows me my router ID, another way to see your router ID. More importantly, it shows me the interfaces that I have placed in the passive state. Back over on router 8 and 9 here on real Cisco IOS do show IP protocols. We're going to see the same thing and take a look. Passive interfaces. When I use passive interface default, it's showing me every single interface on this router, with the exception of Fast Ethernet 00, is in the passive state. So show IP OSPF protocols will show me the interfaces that have been passived. All right, that is going to do it for this tutorial. Again, my videos are about much more than simply type in these 5 commands and you've got 100%. Again, I'm going to get you to the 100%, but I want to make sure that you've got a great understanding end to end of all the material that's being talked about and demonstrated in this packet tracer activity. And I'm going to be doing this for all of the packet tracers, for both the ENSA course as well as the other 2 courses that are part of the new CCNA version 7. I really hope that I earned your time here. I hope that this is a valuable tutorial for you. Please leave me your comments down below. If there's something I didn't touch on or something that wasn't clear in this video, leave me a question and I will do my best to get back to you as soon as I can. Thank you so much for watching. Have a great weekend, happy holidays, and I hope to see you in the next video.